And everyone can hear me okay, presumably? Perfect. So, yeah, let's jump into it. Per usual, start with some logistic stuff. Oh, that's the wrong app. This is the right app. Cool. Midterm will be a week from Monday, so this last Monday. So 5 days from now, not this Friday. I don't really want to give you guys something on what should be a day off. And also, the course staff isn't necessarily available on Friday to answer questions about a midterm. They are on Monday. So we'll have some more staff around that day. So, midterm's now on Monday. You'll have 24 hours to finish it. I'll push that out. It'll be available at midnight that day, and be due at midnight that day. It shouldn't take you more than like an hour, maybe an hour and a half to take it, about what would be class time. If you have accommodations that are different than kind of extra time, where the extra time's kind of already baked in, you can, under your discretion, take as long as you need, as long as it's in that 24-hour window. If you do have accommodations and think that's not quite fair, reach out to me and we can have a little chat. We'll talk that out. I think 24 hours should be plenty of time, though, for this midterm. For this midterm, it's not going to be all that crazy. Yes. I don't know yet. I haven't written it. So it'll be, so to give you an idea what I'm thinking, it'll be a mix of multiple choice, maybe a couple short answers, and then a couple larger kind of comprehensive, do you understand what's going on type questions. So some of it will be very, very objectively graded. Other things will be a little bit more, I have to use discretion to grade stuff. That's on purpose. I need to know that you guys aren't just kind of copying answers down and actually kind of are grasping something in the class. That being said, those questions aren't going to be crazy hard. It's going to be fairly basic understanding, kind of more written out questions. Some of the multiple choice questions will come from past quizzes, others will not. It'll be kind of a grab bag, but it shouldn't be anything that you guys aren't kind of expecting. It'll be a kind of a mix of what was on the homework, questions about homework problems, questions from quizzes, a few new ones that are kind of based off of those two. And that's kind of what it's looking like. It'll probably be, if it was all multiple choice, it would probably be around 50 questions, but it's not going to be all multiple choice. I'd say maybe 30 multiple choice questions, 10 like fill in the blank kind of things, 10 and not 10 short answer, but maybe 2-3 short answer questions. Cool. Just to give you an idea, more on that, I'll put out some discussion on that over the weekend. Yeah, and we'll have kind of extra office hours on Monday that will be there for us to clarify questions and stuff like that. Any questions about the midterm in particular? Yes. I believe 20%. Consult the syllabus. It's on there. I think it's 20%. Same as the final. I think they're both the same. It will cover some of the PL topics we've gone over in the last week. So I think before I said it will just cover functional programming, it will also cover some of the stuff we've gone over in the last 2 weeks. So be aware of that. It won't be necessarily anything we covered this week, but definitely last week's stuff is fair game. A little bit of what I cover today will probably be fair game. And what will be fair game will be pretty clear at the end of class, I think. Will I curve the results? I don't know yet. I like to see usually a low B average, like an 80 to 82. If it's way below that, there probably will be a curve, but it's very rare that I need a curve by more than a point or two. So it's possible, but unlikely. But you guys are all going to ace it, so I won't have to curve it. You guys will all do well. A little secret to you guys, my classes tend to have a higher grade point average than the fall and spring courses. So that's to your benefit, I guess. If there aren't any other questions about okay. So Linnea said, do we have recitation on Monday? Probably not, but I'm not sure yet. I will get back to you on that. I need to talk to Sakanya first. I haven't gotten to talk to her in a few days. Plan on having recitation on Monday, but it very well might not occur. We want to decide how to use that time in the best way. If that's just more office hours, that might be more beneficial. So that being said, we can't really answer the test questions for you, so that also might not be beneficial. Just stand by on that one. And yeah, I'll be talking to her probably the next day about that. So yeah, ask again tomorrow, and hopefully I'll have a better answer. So if there are any other midterm questions, throw those in chat now. Otherwise, any other logistical questions? How'd the homework go? Generally okay. Number 9 was a stumper, I guess. We'll definitely talk about number 9 again, probably tomorrow. I do want to go over that, but I want to grade a few assignments first. That'll be tomorrow, hopefully. So
I'd like to confirm with you that that if we submitted homework 2 before changes were made, so if we have a homework 2 that works with the original standard library, it'll be graded in that standard library.
Yeah, you'll be good. We'll use both to test it, as long as you have a correct, like we do look at every problem. If you get a problem wrong, we're looking at why. And we would know immediately if that was the case. They're also named differently, so we'll know right away which one you used. So yeah, you're all good there. And if not, it's very possible you get that wrong when we grade and goof something up. Just say something and we'll go back and fix it. So as long as you got the correct solution for number 9 using one of the 2 libraries, that's good for us. So thank you. That's a very good question there. I think originally when I put out a notice or an announcement the other day, I said homework 3, I'd give you a couple days. I think I gave you a day. So homework 3 is out. You should be able to do all of it, I think, as of right now. It's somewhat longer, but you've written the functions before in some cases. So it's not super new. And we did actually just about everything we've done in class before. So we have you define the integers, which we'll use in our interpreters later going forward. We'll swap out integers for the natural numbers this week. So we have you define the integers and then define the functions, the arithmetic functions on those. So plus, minus, multiply, divide, and power, I think. Absolute value maybe, as well as negation. Pretty straightforward functions. They're not all that hard to write. Some of them are a little tricky, especially addition. Actually gets quite a bit more difficult, but not too crazy. So as long as you kind of tackle it in pieces, chop it up, it's not too bad. We also have you define a first interpreter using the natural numbers. We actually did that in class last week, so it should just be kind of transcribing that over. And that's out now. It'll be due 1 week from today at midnight. More than enough time to do this. I think I'll be typing up the solutions again. So I just want to go through the problems again myself, but it'll take me 20 minutes to write them out. I'd expect you guys to take an hour or 2 maybe to do the homework. Shouldn't take all that long. If you have a complete understanding of everything. Obviously, if you hit a hang up, that's a little different. But, any other questions about logistics stuff? I think I hit everything I needed to hit. Thanks for bearing with me yesterday. So I was telling people in the classroom already, but for those online, I was supposed to move on Saturday. I showed up to my new apartment. There was no carpet on the ground, so I couldn't actually move when I was planning to. Had to do that yesterday. I appreciate you guys kind of playing ball with me and kind of bearing with me there. It is appreciated. Hopefully you all enjoyed the day off. I think everyone in class is nodding their heads. Yeah, don't foresee that happening again, so that's good. But otherwise, if there aren't any other questions, let's jump into today's material. So here's a little reminder of kind of what we covered last week. So we started defining this small language on arithmetic using the natural numbers, so not integers, but the naturals. We did plus, minus. Did we do minus? I think we did minus last week. Multiply, divide, and power. I don't think we did divide last week, but that behaves in a way you would expect. The only thing is that there's a chance you get a divide by 0 error. So if you have 0 in the denominator, you'd have another error thrown. Just be aware of that. It's not huge. You will have to implement that at some point, but we'll talk about the inference rules for that later. You also have a couple values. You have num value and you have error, and then all those semantic rules we went over. Oh, okay. So Joseph, I just saw your message in Zoom. Joseph says, would appreciate the recitation still on Monday. Examples in Scala Code are super valuable for the homework, and I'd rather not miss a week. Yeah, I'll take that into consideration. I think maybe let's plan on having recitation on Monday for now, maybe with optional attendance, which it always sort of is, but we would understand, and it's obviously recorded, so, or should be recorded at least, I think. Yeah, so let's plan on having it for now. Unless something comes up or something. So yeah, thanks for that input. I like that. Yeah, so we went over all this last week. Now I'd like to ask, how can we improve this language? So there's a weakness that this language has so far. And here are 2 examples that hopefully kind of bear out the weakness of our language, or one of the weaknesses of our language. Take a look at these examples, and do you notice any patterns? Do you notice something about the language we could improve that would make these small little expressions a little bit better in some way? And I won't define better. We'll talk about that a little bit, but what do we see? Yeah, Colin.
Oh, well, for example, if it's like told the computer, the interpreter, to like go for parentheses first, it would do that 4 times 2 and then add 3 to it, and then it would sort of have that operation set memorized for the next set of parentheses it goes to.
Okay, so but what's the pattern you're noticing, right?
So they're the same set of operations.
Yeah, there's a repeated set of operations that happen over and over again, right? And so your suggestion was, let's improve the language by saying, okay, well, when we see parentheses, maybe look up that value that's already been computed. We'll do something similar to that, but in a little bit more of a kind of hands-on way. So there's a way you could do that automatically that compilers sometimes do. Does anyone remember from your algorithms class what it's called when instead of computing a value, you go and look it up from a table that you've already computed? So caching is one word we call it, but not in algorithms land. It's called cache just about everywhere else.
Is it hash?
Not a hash. Sometimes you store these in hashes. Word starts with an M. Memoization. Yeah, so you guys memoize, right? Which is, I always thought it kind of a dumb word. Memorize, maybe. It's like there's supposed to be a link there. Yeah, so you can memoize it. Compilers sometimes do this. It's not super often they do, but sometimes they'll do this. More often they'll actually do an abstraction that we're going to see today in class. Mike says he only calls it that at parties. I like that. Yeah, otherwise we usually call them caches, right? I'm sure there's some distinction a networking person or a systems person would tell us that those aren't the same thing. I'm not certain where the distinction lies, but yeah, so we could, there's this idea of repeated values. So why are you computing them over and over again? Now, does that hold for the second example as well? Not exactly, right? So there's not a repeated operation in the second one, but what is true about the second that's also true about the first example? Yeah, it's like a repeated number. It's kind of long and painful to write. Is there something similar to that in the first expression? I'd argue there is, right? So in the first expression, we have this kind of runtime overhead, but it's also a pain in the butt to type in 4 times 2 plus 3 a bunch of times as well. In the second example, you're typing in that long number a bunch of times. So there's kind of a programmer headache at play too. Let's see if we can't maybe solve both of those problems at once. And I think we can. So yeah, let's write down there are repeated expressions that A are a pain to type a bunch of times, and B may be inefficient at runtime. Now, how might we solve that problem? What could we do to solve that? There we go, Ben. So Ben Spicer says, are we introducing variables here? So you could introduce variables, right? This is what variables are good at, is kind of saying, hey, we're going to use this thing a bunch. Let's give it a variable name and put the variable name in place of the number, right? Or the expression as well. Yeah, so we're going to do just that. And we're going to do this through a construct called the let expression. And I think we'll actually just show examples instead of trying to formally define this. We'll formally define it a little bit later, of course. So for our first example, instead of writing this big long thing, I might instead write let x equal 4 times 2 plus 3 in x plus x over 7 minus x times 2. Okay, and I think we could all agree that that's probably quite a bit more appealing to write, right? So it's both going to increase our efficiency at runtime, right? We're only going to be computing this once when we encounter the variable. We'll say, okay, well, we'll keep track of this number as x from now on. And then we plug it in anywhere we see an x. Okay, better runtime speed. I also don't have to write this 3 times. I can just put x in its place. And then for the second one, that this guy, we could do something quite similar. So we could say let x, or say let y equal 105,279 in y times 5 minus y over 3, right? So better, right? It's a little bit more like, it's more ergonomic for the programmer. It's much, much easier on the programmer. It's gonna sometimes introduce runtime improvements. Here it doesn't necessarily. When does it improve runtime performance? Yeah.
In the top one,
Mhm.
when it only has to like calculate it once.
Yeah, when it's calculating stuff. So when there are operations, right? So if there's a value for y, like here, it's not going to be any faster, but it will be easier for the programmer. Technically, it'll actually be a little touch slower, but that's kind of okay. Whereas in this top one, we're doing multiple operations over and over again. So that's where we would see a bit of a runtime performance increase, right? The reason we care about this in programming languages though, is usually because we want the programmer to have an easier time programming. The efficiency is kind of second to that in some respect. So Yeah, Arthur says object-oriented programming hype. No, I really hate object-oriented programming. We're not going there with this. But eventually you do kind of get there if you take kind of one route with this kind of method, right? Cool. So let's look at a couple examples of programs that use let expressions. And these are, again, just more examples. And let's just see if we can evaluate them. Okay, you'll also notice that there, in a couple of these examples, we'll start seeing some Boolean values pop up. Assume we have syntax for that. We'll also define that kind of as we go. So here's another example. And I want to ask you, what does this evaluate to? Okay, so we're just kind of practicing. What do they evaluate to? Getting a feel for the language before we start trying to define it. Okay, so we could do something like let x equal 25 in let y equal pow, and actually I'll write this in the concrete, say x to the 4 in let z equal x is greater than or equal to y in if z then y else x. What does this evaluate to? What do we think? 25, I'm here 25 in class. Online, Noah's saying 25. I like it, 25. Now, why 25? Walk me through that answer. Go ahead, Aaron. Yeah.
Y would be 25 to the 4th.
Would not be 100, but it'd be a really big number, right? Yeah.
So then x is not greater than y. So z is not true.
Right, z is not true. So then you go to the else case, right? Perfect. And then you get 25 out. Yeah, obviously a very carefully orchestrated example, so we don't have to use big numbers, right? Cool. So 25 there. Let's do another example. And here we're just getting a feel, and this is something we'll often do when we start designing programming languages, is we'll often play with a bunch of examples before trying to formalize or implement anything. We'll just kind of get a feel for it, figure out where the corner cases are, and there often are corner cases. As we'll see here in a second, actually with this example, I believe. No, with the next example, not quite this one. We'll see some issues pop up later. So let's do let x equal 10 in let y equal x plus 10 in z and let z equal y plus 10 in x plus y plus z. Good question, Mike. So Mike asks, what does the keyword in mean here? So in is just kind of a delineator here that says, this is what X is allowed to occur in. Okay, so it kind of means almost literally what you would expect it to mean in English. It just says that the variable we just declared in the let appears in this expression somewhere, or can appear in this expression. Cool. So we actually will always see a let. I'll show you after this example, but there's a form that this takes. A let and in always occur together. You can never have a let without an in. You can never have in without let. Cool. Yeah, so the question is, this is kind of like the using variable function thing in C# and maybe other languages. For those of you in class, that probably didn't make sense. For those online, you can read that. Yes, it is fairly similar to that. Not exactly the same, but similar. Okay, do we have any results for this problem? Yes. I think it's 60. I think that sounds right. 10, then 20, and 30. Yeah, so 60. Cool.
Quick question: is there scope to these variables that you let? Like,
Ooh, good question. You're anticipating my next example, so I'm gonna have you guys answer that question for me here in a second. So here, let's do this. So let X equal 7 in let Y equal 8 in let X equal Y plus X in X. Pseudo, take a closer look at the previous problem. Try it again, and if it doesn't make sense, we can go back. Does anyone have a result yet? You guess so? How about online? Does anyone have any thoughts?
Well, are variables values set when they are assigned and require special syntax to change them, or are they mutable?
They are immutable.
Okay.
Variables are always going to be immutable in this class unless we say they're mutable.
So then would in let X equals Y plus X be invalid syntax?
No, it is not invalid syntax.
So the variable X is mutable then?
It's not quite mutable, because mutation actually assumes what we call state. And maybe that's a subtle distinction we will get to, actually not even till next week, I don't think. Yes. Okay, so yeah, so let's talk about this one. In the next example, I think the mutability problem will get answered in a little bit better of a way. So here, how we evaluate this, and I'll just walk us through this one. For those of you that said 15, you're correct. And I actually don't know as though anyone said 15, because you're thinking actually very literally about what I said. They're immutable, but mutability is a slightly different idea than what's at play here. here we have x equals 7, right? So let's keep track, maybe in a little ledger on the side, what each of the values are as we execute. So in this first line, we have x equals 7, or x maps to 7. In the second, we have x maps to 7, y maps to 8. In this next one, this x is actually sort of a different x. We call this shadowing. So here, we actually have both x's in our ledger, but now x has the value y plus x. When we do this y plus x, we look up here for the values, and we get 15, and then output x. When we look for an x, we always look from the bottom up. So this is our value for x. Now, why this isn't mutability will be clear with the next example. So like I said, bear with me for a second, and it'll be more clear. Yeah, so Ronak, correct me if I'm saying your name wrong, but is the x we created inside technically a new x then? Yes, it's a new x. It's not really the same x. So this isn't like making a contradiction. It's actually just a new variable that we've shadowed. We said the old one we don't need anymore, kind of. It's no longer useful to us. We're throwing it out whenever we override a name. It's a different place in memory. The old x is still kind of there, and we'll see in a second why it has to still be there. So. Cool, so let me add another page. So we do get 15 for this. And this example should kind of show why this isn't quite mutability in that classic sense. So bear with me because I think I need to come up with this one on the fly. So let x equal 3. And we can also write the ends up top. It doesn't really matter. Again, white space doesn't really matter to us. That still holds. And here then let y equal 5 in let z equal, and then inside of here, I'm going to put some parentheses. And because the right-hand side of a let expression is always allowed to have an expression, not just numbers, we can say let x equal 5 in x plus x. Actually, just for variety, let's do x plus y. In z. What's the value for z? Or actually, instead, let's do z plus x to really make, kind of hammer the point home. A lot of people are saying 13. I'm getting 13 in chat. I'm also getting 10 in chat. Let's take a look at why. Actually, Graham, take another look at your 10, because I'm not sure necessarily how you got it. Unless you did it when I had x plus x, then that would make more sense. So let's draw that little ledger again on the side as we evaluate things. This is going to be a handy tool, keeping kind of a piece of paper around where we kind of pretend we have memory, right? So here, first line of code, we have x equals 3. So let's do x maps to 3. Now we get down to y maps to 5. Okay, now we get down to z. We're working on the z maps to. We don't know what goes there yet, but we're working on it. And then while we're working on that, we encounter another let expression. When we see that, okay, we're going to kind of pretend that we're on a separate sheet of paper while we're calculating z. Okay. You could also pretend we're kind of below the paper, or kind of on the next line, but we got to then cross out the x, but we'll get to that in a second. So on a separate kind of line, we have x maps to 5 and then do x plus y. What is x plus y? X plus y is 5 plus 5 from the y and the x respectively. It's not the x equals 3 because this is for the z, right? That's where that in part matters a lot. And so this ends up being 10. And then if we had drawn X maps to 5 here, that would have been fine, but then we cross it out. We're done with it. And now our X value goes back to being 3. So we have an updated X, right? No updating happening here. Get rid of that sheet of paper. We get Z plus X. 13 is our result. Questions? Big takeaway here is we can nest our lets. We can both nest them going down, kind of in the in part of let, but we can also put them inside the let binding itself and create programs there. Because why not? You know, if you're dealing with expressions, you might see repeated things that you want to put in a binding that's not exclusive to any part of the program. You don't want to limit yourself. Put it anywhere, right? Okay, Graham, I just saw that. Thank you. I figured that's what that was. It was the old X plus X part. That's what I figured. Cool. So what's the form of this let binding? So here we have let variable name equal expression in expression. That's our form, the form of a let binding. Okay, so hopefully this answers a few of the questions, right? This is why we have in delineates each of the expressions, right? It makes it really clear which one's which. And then it also, importantly, we have an expression for variable names. So we can plug in other let bindings. We can plug in anything from arithmetic that we already had. As we saw earlier, we can also throw Booleans into there. We haven't formally introduced Booleans to the system yet, but we will be. Or we kind of just have, actually. We'll formally define those later. So this is a really versatile construct. You can really use it anywhere where you would need a variable binding. If we hadn't let this be an expression, if we required that to be, say, maybe an arithmetic expression plus variables, we might hit a little problem, right? We'd still have that repetition issue pop up. Cool. Let's add this to our language now. So remember, we have our syntax, we have our semantics. We start with the syntax. We need to create an expression for this. I'm going to give you guys a minute to try defining expressions for let, and we also need an expression for variables. So we need 2 new expressions. And while you guys are working on that, I'll give you a couple minutes to try that out, play with it, because I need to use the restroom. So I will be right back. All righty, what are we thinking? So I have a question already. We'll let output a nat. So we're not worried about the semantics yet, just the form of the expressions. So we don't need to worry about what it evaluates to quite yet. Colin, what are we thinking?
Sort of like how we define of a nat to do like variable of like a.
Okay, so we could write something maybe like var, and then what should go with it instead of like a, but we don't want to really be polymorphic here.
Yeah, okay, then we could just call it like variable name or something.
Yeah, what's the type of a good name? Strings, right? So we can just do var and then string. You could put name there. I mean, we could use numbers to denote variables. We could use a whole lot of stuff. We're not going to, but we certainly could. You could use programs as names, but that introduces a whole bunch of problems. You don't want to end up doing that. You write the thing. Okay, so Arthur's question, how do we write the thing if we don't know what it evaluates to? I feel like I'm making missing something obvious. So we kind of do know what it evaluates to. That's more in the semantic domain. So right now we're just worried about really the syntax of it. It will evaluate to a value, right? Because our programs always evaluate to values, either a num val or an error, right? So you're right in thinking it evaluates to a nat. But we're not quite there yet. We actually won't touch on that until tomorrow, mostly because we won't have enough time to start defining the semantics quite yet today. I don't think we might actually have time. We're moving pretty quick. So var, we're going to use strings as our names for variables. I like that. Nice and simple, right? Doesn't need to be too complicated. How about our let expressions? What's their abstract syntax for that? So you can start by just calling it let for a constructor name, right? But what does let take? So let takes a var. Does it take a var or a name? This is a subtle distinction, right? It's going to end up taking a string, right? It won't take a var because a var is a constructor and expression. We don't want it to take an expression, right? Because then you could put numbers there. So we'll have it take a string, which is that variable name. So right on, Joseph, I like that. And what else does it take? Two expressions. And two expressions. What about that in keyword? Do we need to represent that here?
But it's sort of how in like a minus, it's implied that the second one's coming off the first one.
Mm-hmm.
It could be implied that this is to the end part.
Yeah, like the second expressions after in. Yeah, so this is that concrete versus abstract syntax thing again. So remember that let x equal, say, 5 in x. This is concrete syntax. This is actually a concrete program, right? Whereas if we were to fill this let expression out, we'd have let x string be var, or not var, sorry, I'm getting ahead of myself, be num 5. And then the in is kind of there after the comma, right? It's just kind of, or it's kind of in the comma. It is the comma, sort of. In var x. And that's our abstract syntax. And remember, the concrete syntax is what our programmers that use our language are writing, or that if we're writing in our program, programming language, we'll write the stuff on the left-hand side, that concrete syntax. If we're a language designer designing an interpreter or compiler, we're probably using the right-hand side, that abstract syntax. Does anyone remember why we prefer abstract syntax here? This is definitely a question that'd be on the final or on the midterm, I mean. Why do we prefer abstract syntax for like writing interpreters over something like a concrete syntax? Yeah. Yeah, that's part of it. So like concrete syntax introduces all these problems of parsing, right? And also things like parentheses become an issue. They're really not in the domain of, you know, does the language work? It's not really in that domain, or what's the evaluation? It's less ambiguous is really kind of what it's all about. It's very clear about what all the parts are. There's another thought I had about that. It also just so happens to be really similar to Scala's constructors, Haskell's constructors, that make it really easy to actually program these things as data types. So that's an added benefit. Not required, but it's an added benefit. So we do like that. You know, it's very close to these functional languages, right? So that's the other added benefit. So definitely know that. That's really important. So I'll kind of write some notes here, easier to write. It is harder to parse, whereas this is easy to write interpreters for. It's unambiguous. And it's similar to data types in functional languages. Cool. Any questions about that or anything really up to now? Questions?
Sure. In the concrete syntax, you don't have any parentheses. Although I believe I heard you correctly when you said concrete syntax would have problems of parsing things like parentheses. But then in the abstract syntax, we do have parentheses and commas.
Oh,
and
yeah. I see where you're going. So the concrete syntax has ambiguity in stuff like order of operations. And so you would need stuff like parentheses in order to make it unambiguous, right? So for instance, something like 5 minus 5 plus 5 could be parsed as either minus 5 plus 5 and 5. Abusing our abstract syntax a little bit here. This should have nums wrapped around them all, but that's okay. Or it could be parsed as plus minus 5 and 5 and 5, like so. Both of those would be correct parses. So you would have to introduce parentheses in order to disambiguate that. Whereas our abstract syntax obviously doesn't have that problem. That's always decided for us. So when we do work in kind of language prototyping, we just remove the need to even worry about that concern by using abstract syntax. Because ultimately, like how that works, that's not really interesting for a language designer. We don't care about that. It's fine for someone designing a parser, and they can decide maybe, you know, how do we want to deal with parentheses and order of operations. That's for someone designing a parser to decide, which is often a language designer, but it's a different kind of concern, and it doesn't actually need to be baked into the language itself. Language itself is a little bit, abstracted from that, if that makes sense. Does that clear that up?
I believe so, yeah.
Okay, cool. We can definitely keep talking about that too. If, raise a question tomorrow at the beginning of class, we can chat through that a little bit more, but hopefully that's unambiguous kind of for why I made that claim. Yeah, because obviously there are parentheses with the abstract syntax, which is part of the reason why it deals with the parenthesis problem, right? So it's not that parentheses solve the concrete syntax problem. The problem with concrete syntax is really that you might not always have parentheses. That makes sense. So,
well, I suppose I
yeah.
have some confusion about what exactly. So the abstract syntax seems to deal with atomic units, wherein the concrete syntax, just taking those two statements you have there, would seem to essentially have two, call them atomic units. Like you have let x equals 5, which is what we have on the right hand side. But then we also have in x, which is another expression which doesn't seem to be represented in the abstract syntax.
So the in x is representing the abstract syntax, right? In that it's this part of the abstract syntax, right? It's part of the let expression. Where, and that's another.
If you had an expression, it would just be nested in your abstract syntax?
Yeah, so if I had, say, the in x, it would be nested inside of this bit. So say x wasn't just x, it was something more complicated, it would just appear right here as the third argument in the let. So, and that brings up another interesting point, is the concrete syntax, you could also have erroneous concrete syntax, right? Where maybe I left off the bottom line, and that would be a nonsense program. And you'd have to parse that away. You get a parse error. But that's something you have to deal with concrete syntax that you don't really have to deal with abstract syntax. You have not well-formed abstract syntax, but it's really easy to figure out. It's harder with concrete syntax. So, we all good? Any other questions about that topic? Cool, so that's where we've gotten with our, so I need to find my mouse, with our expressions. Let me check the battery on the laptop real quick, so we're playing it safe. We are good. Thanks for bearing with me. And then what do we want to cover next? I don't think we want to cover well-formedness. Ooh, yeah, so let's start talking about how to add Booleans to this as well. So let's copy down these expressions again. So we've added var and let. Let's talk about what other syntax we need to add for Boolean expressions, because we obviously have those in examples. They're really useful in programs because they eventually allow us to branch, right? I'll duplicate this again, scroll down. What might we add in order to support Booleans? What do we need for Booleans? Yeah, so we need to start with like a bool type or an expression for bools. Yeah, and then other constructors for statements about bools. Yeah, thanks for that, Mike. So yeah, so Graham gives it. We add to expression bool b. So we'll call this bool in your, I think in Scala, we're going to call it bin for binary value, but here we'll just call it bool and give it a bool as an argument. So it's just wrapping up bools into the expressions, right? So now we can have a bool for an expression. That's all legitimate. Let's see. What else might we add? So just bools on their own are pretty uninteresting. We can't really do anything with them. What might we add so that we can actually use the Booleans?
statements.
Yeah, so we could add if statements, right? If then else. So we'll add if then else. What does if then else take as arguments? A bool at the beginning. Should it be a boolean?
You could just say expression. It has to be an expression that evaluates.
It has to be an expression that evaluates to a boolean. I like that you're thinking ahead a little bit. Yeah, so we'll just give it an expr. And then what else should it take? Two other expressions for each of the branches, right? Cool, I like it. What else might we add for supporting kind of the booleans? So I'm using if then else. What if I want to check two different conditions? What do I need?
Your logical operators.
Yeah, I need all my logical operators. I need and, or. I could throw XOR in there. I don't think we'll throw XOR in yet. But yeah, so we definitely and or. So and will take two exprs. Or we'll take two exprs. We should also probably throw a negation in there, not. And not can take an expr. And then what happens, how do we kind of relate the booleans and the numbers together? Like, often I want to say something about numbers, right? And there are certain like predicates on numbers, like comparing numbers.
Less than or equal to.
Yes, like less than or equal to. So we'll add LEQ, GEQ. Those will both take two expressions. What other way could we compare two numbers? Actually, numbers share a certain type of comparison that also the booleans have. Does anyone know what that is? Oh, Mike just did it. Yep. So equals, right? So actual equality. So we just have EQ. And now what's special about EQ? Well, for those expressions, I could also have numbers be compared, but I could also have booleans be compared, right? So equality is a little bit more of a wide-ranging thing here. Do I want to necessarily have cross-pollination there? Could I compare, say, ask, is this Boolean equal to this number? It's not a good idea.
I guess unless you wanted to have like false equals 0.
Yeah, so you could have false and true equals 0. You could also have them not be, right? I could also check like, is false equal to 5? You know, or even have false equal to 0 be false, because they're not really the same thing. You could also have them be the same thing. So you may do that. We're not going to. We're going to say that comparing a number to a Boolean is either an error or it's false for our sake. But that's into semantics, right? So we won't get there until tomorrow. We'll put that off for now. Anything else you guys think we should add? That's all I had, but we could definitely add more. Anyone have any thoughts? NAND? Yeah, let's throw NAND on there. Why not? We could come up with some fun operator for that as a class, right? Cool. Yeah, if anyone has any kind of interesting novel suggestions, go ahead and throw those in there. I don't mind doing, Yeah, we can definitely, if you guys have an area you want to take this programming language, you think something would be cool to try out, say something. We can definitely explore it. I'd have a lot of fun doing that too. So NAND is kind of low hanging fruit, but we could imagine some pretty wild stuff, I'm sure. Let's see. What values can our program take now? So we're kind of just going to start talking a little bit at the end here about the semantics. So we're not going to actually do any of the evaluations, but what values can our programs take now? Any thoughts? So before we had val, right? Val had numVal n. That one's still going to be around, right? We're not getting rid of that. We also had error. We're not going to get rid of error. Error is going to hang out. What else might we have? Mike, can you elaborate? I think you're on the right track, but I'm not positive. What could our evaluations be? So we introduced Booleans, right? So we could also have Boolean values for our programs, right? Is that fair? Okay, so we could also have the bool val. And that's just a Boolean. Can we get anything else? I think that's it. There's a couple new kinds of errors we could have pop up. Does anyone have an idea of what one might be based off the syntax?
One type, wrong type.
Yeah, so we could have type errors now. So for example, we could have something like plus num5 and bool true, and we have a type mismatch here. Should we maybe create multiple error types or multiple, sorry, values for errors? Because right now we just have error. It doesn't say anything other than it's an error, and it could be any kind of error, right? So we could do that. So let's do that for just a few kinds of error, right? So we have error. We can leave that as a general error. So maybe just keep that around just in case. But we could also add a type error. Okay, doesn't take any arguments, it's just there. We could also have, we have division, so we could have a divide by 0 error. We won't add negative number errors because we're going to make those go away soon. We're going to start using the integers soon. So we won't add that, but we'll have those too. So a more specific type for errors. What's another way we could deal with this kind of like errors not being specific enough problem? Because you could define an error for a whole lot of stuff and a whole bunch of constructors for that, right? But what else could we do? Do a lookup table. I don't love that. Or we could give error a string, or maybe a number. A number would work too. So we could actually give error a string as well. So let's do that as well on top of it. You know, and I'll probably condense these down to just, I'll probably remove type error and divide by 0 error tomorrow. We'll probably just use error in a string to tell us what kind of error it is. But it's definitely useful to know what kind of error you have. You don't just want error. You could also say something about it. So that's very useful. Yeah, and good job, Mike, with error codes. You know, and those could be numbers, but we have strings here, so why not use them, right? What else could we do there? Yeah, I don't want to get into evaluation yet. I only have 5 minutes left, so I think we're going to call it there for the day. Are there any questions though before we wrap up? Can we get strings from programs if it returns a variable? Oh, Linnea, good question. So if I have, say, we return a variable as for our expression, could that variable be a string? Yeah, so there might be a problem where we kind of like use a variable that hasn't been declared. That's a different kind of error. We're not going to allow for string output yet. We will add strings, but that's in a later homework. So yeah, Linnea, no, we won't allow for any kind of like string output. But if you have an undefined value, that's another type of error. So that's why we're going to kind of collapse these all into one error constructor tomorrow. So cool. Well, everyone have a good evening. I'll hang out for a minute or two if you have any quick questions. Otherwise, see y'all tomorrow, and have a good one.